Good afternoon, everyone. This is Dr. Solomon. I will be your instructor for the CENG 3351 Transportation Engineering. I welcome you to the class. Today, we're going to start with the first lecture of the class, and it's going to be an overall introduction to the transportation engineering systems. So, first of all, again, I always like to give you what are the learning objectives of today's lesson. So first, we would like to accomplish today one of the major things is to define what do I mean by transportation system, and then we will be able to explain what's the transportation engineering from three different areas of involvements. So as a transportation engineer, you will be dealing with planning, design, and all the other engineering aspects. So planning design is basically you will be handling operations and management. How can you manage and operate a full network? And when I say a network, it's basically a city, like our own city. So anybody already knows what's the difference between transportation engineering and traffic engineering? So I guess again, I'll leave that to you, but I would like to know what's what's your perspective on what's the difference between transportation engineering and traffic engineering, which is an advanced class that we will cover in the following semesters. And the other objective that we would like to cover today is to introduce you to the transportation related organizations and professional societies that you might be interested to join if you decided that transportation engineering is your future career. And finally, we will be explaining transportation engineer as an overall profession. So some definitions that is related to transportation system. So what is a transportation system? It's really a full system that consists of fixed facilities and the flow entities and the control system that permit people as well as goods to overcome the friction of geographical space effectively and efficiently in order to participate in timely manner in some desired activities. So what is that all about? It's basically a transportation system. We're trying to move things um, things and as well as human beings. So we move from point A to point B. So that's us. We send things over Amazon. We ship things from point A to point B. That's goods. How are we moving this? We have to have fixed facilities. Those fixed facilities are, for example, a facility as a highway intersection or a highway, for example, I-20. That's a fixed facility that we use to move goods and people from point A to point B. The flow entities, again, it's us, and we use control system. How can we control movements? So for example, in our own city, we use traffic control signals, we use markings, we use signs. So all those are control systems that permit or that give the indication to the people and the goods to move from point A to point B in an efficient way and also in a timely manner. Now we will discuss the system functional component. In any transportation system, there are several components. As we said, the first one is the fixed facilities. So fixed facilities includes transportation networks. It can be physical or virtual, and it contains both items, links and nodes. So the links are the roadway segments themselves. They can be the railroad or railway track. They can be pipelines if we're transporting gas or liquids. They can be flights. They can be fiber optics. When it comes to the nodes for any transportation system, those includes intersections, bus terminals, airports, harbors, warehouses, interchanges, even routers. So again, that's what I mean by fixed facility. So for example, if I leave from here to another city, I will go through some nodes, which are intersections or bus terminal. And then once I leave the bus terminal or once I leave the intersection, I will be using the link, which is a long segment or a long highway to get me from city A to city B. Another component of any transportation system is the flow entities. Who are we transporting. As we said before, we're mainly transporting passengers, we're transporting vehicles or containers or even data from point A to point B. That is transportation. When it comes to passengers, one of the most fascinating aspect in transportation engineering is that we deal with human factor. With all respect to the other areas in civil engineering, as structural or environmental, we don't deal much with human factor. But when it comes to transportation engineering, we deal a lot with human factors. When it comes to operators' physical and psychological activity of the driver, that's a big factor. It can, and how the drivers are interacting with each other, and how are they interacting with some fixed facilities during the operation. So when I say fixed facilities again, how is the drivers dealing with a traffic signal or a marking or a warning sign? That's an important aspect that we need to include, and we need to have it in our calculation when we design a transportation system. It also include travel behavior. So travel behavior, which is again the how we react to traffic control devices. For example, as I said before, pavement marking, the visibility under different colors, size, shape, and weather conditions. So that would make a difference if I'm driving, and how from person number one to person number two, how are they dealing with the pavement marking, the color of it, the size, the shape. How about the signal lights itself? That's also another important aspect. Stop or run. That's also, we're going to talk about this later on in the course, dilemma zone. When we get close to an intersection and you're not sure whether to speed up and clear the intersection or to push hard on the brakes and stop and have a safe stop before you have the opposite traffic is moving. That's also important. How about radio and radio news? Or nowadays we can replace it with Google Maps. If the Google Maps says or tells you that there's a congestion on I-20 East milepost number 10, is that true or false? Would you be able to trust it? Would you be able to utilize that type of an app? Will this location will be still congested by the time you go to that location or not? So many times you hit the road from Tyler to, let's say, Dallas, and there is an accident in Dallas, and Google Map tells you that it will be taking you 2.5 hours instead of 2 hours, but you don't know why by the time you reach there, is it really gonna be the accident, is it gonna have an effect or not? That's also an important factor. Do I need to change my departure time, or do I need to change my route? Instead of taking I-20, shall I take another roadway that goes through Canton instead, while again my approach is Dallas? So all those things again is under the flow entities for any transportation system. How about vehicles? Vehicle also is another component that is very needed to, again, that we need to know a lot about when we design our transportation system. So vehicles, it depends on the size, it depends on the weight, it depends on what's the properties of that vehicle, and when it comes to acceleration versus deceleration. If I'm a traffic engineer, I am dealing with a wide spectrum of vehicle performances, and I need to make sure that I am handling all those extremes, from old cars that they do not have some of the safety features, all the way to the up-to-date cars that they have all what we need to have a safe transportation system. Another component for any traffic and transportation system is control system itself. So I can have the entities, which is people and goods. I need to know about the vehicles, but also I need to know about the control system. How do we control traffic movements? First of all, you need to know what's the vehicle, how can I control the vehicle? So, and that applies to individual vehicles, but also I need to control the flow control, the overall flow. So if I'm talking about a queue of cars or streams of vehicles, that again will apply to all vehicles. So we need to understand as traffic engineers what's the mechanism to guide the flow entities to efficiently and safely transverse through the fixed facilities. There are some mandatory flow control devices, and some of them are advisory. So the mandatory ones, they have to be visible. You can see them easily, and those are traffic control devices. They have three levels. The first level is intersection signals, or traffic signs or pavement markings, and the other level would be, if I don't have signals, it would be this stop sign or yield sign, or sometimes the third level would be again with there's nothing there. If the traffic is not that much, you don't need traffic control devices. Other mandatory traffic control devices, such as air traffic control or toll booth. Some of the advisory ones, which can be hearable, are the traffic information, such as the radio, or the dynamic message signs or Google Maps. All those, again, you can hear them while you're driving, as well as the intelligent transportation system, which again utilize different technologies such as hardwares and softwares. Um, Sometimes they can be either mandatory or advisory, but a good example for ITS nowadays is, again, Google Maps, Waze, other apps that can really tell you how long it's going to take you to go from point A to point B, and it's going to be very interactive with you to tell you what's the update on the traffic, if there is an accident, if there is some um, a school zone, if there is construction zone. Those type of intelligent transportation system apps will be able to tell you a better and give you a better judgment when and how to reach your point of destination. Another, now the system activity characteristics. How can we characterize the transportation system? First of all, I need to have a desired activity. What does that mean? So transportation involves the movement of people and goods, as we mentioned previously. So basically, when you move people and goods, you're changing things in the space and time, and utility. So what does that mean? Utility is a measure of satisfaction or usefulness. If I'm moving from point A to point B, I can go through different routes, but I need to know which one is the best, which one is the most safe, and the safest and the most efficient. Transportation, therefore, is not an end result by itself. You are not going from point A to point B just because you want to drive. It occurs to satisfy the demand for some activities at the destination. What does that mean? For example, if you're going for a job interview from Tyler to Dallas, you will be driving for 2.5 hours roughly to get to Dallas, not for the sake of driving. You are transporting from the Tyler to Dallas because you want to reach your destination to have the job interview. So, and that's what I mean by it's a derived utility, or it's a derived need as a transportation. We go to school. Most of you, again, you come to school again on a daily basis, and you use your cars and you drive from your homes, your apartments to the campus. Why do you drive? It's not just because you love driving, it's because, again, it's gonna get you to where you need to take your classes. So as I say, transportation is really a derived demand. Another characteristic of any good transportation system, it has to be efficient. So efficiency, one of the aspects of having an efficient transportation system, it has to be cheap, it has to be safe, it has to be quick. We often conflict the requirements of how can I balance between safety and economic. Again, safety will always be number one, but you also have to keep in mind the available budget and how can you make the transportation system that you're designing as safe as possible with the least amount of budget. As I said, there are two dimensions when it comes to transportation system, time and space. So when I need to get people from point A to point B, it has to be timely. You can't be too late for an interview. You can't be too late for a lecture. You can't be too late to go to a hospital. Again, that's not, you can't afford that. But sometimes also, again, too early is not desirable either. Also, when it comes to space, you have to overcome geographical spaces. If you're designing a transportation facility from point A to point B, you need to make sure that you'll be able to handle all the geographical changes, including different elevations, different horizontal alignments and vertical alignments that we will cover later on in the course. You may need to include and cross a bridge or continents or even oceans. So all these, again, some of the characteristics of transportation systems. Now let's shift gears. So what do I mean by transportation engineering? So transportation engineering is the application of any technological and scientific principles to the planning, functional design, operation, and management to the facilities for any mode of transportation. There are three areas of involvement when it comes to transportation engineering. We will be covering planning, and that will be chapter 7 and 8, design a transportation system, and that will be chapter 2, and then a big portion of this class will be operation and management, and those will be covered in chapters 3 to chapter 6. So let's talk about the first aspect of transportation engineering, which is planning. So the planning aspects of transportation engineering relate to urban planning and involve technical forecasting decisions and more difficult political factors. So planning, again, is not an easy task. And your goal as a traffic engineer, if you decided that planning is your niche, you are going to be predicting and you want to forecast what's going to happen in the future, how much demand am I expecting to see on those highways, and this is also again going to affect lots of political factors and political decisions. Technical forecasting or urban passenger traffic presently involves what is called the four steps. So there are four steps when it comes to predicting and planning any transportation system. The first one is trip generation. You need to ask yourself how many trips and for what purpose? How many trips are people are going to take from Tyler to Dallas per day, per week, per year? And what are the reasons for people to move from Tyler to Dallas and backwards? The next question or the next step in any planning process is trip distribution. What does that mean? Well, that means destination choice. Where are people going? Where are people heading from point A to point B? The third step is the mode choice, which means again what mode is being taken. Mode choice, that means again you can travel by your own vehicle. People sometimes they may take a bus, they may bike if they are within the city from for example from the campus to their apartments. Students may take a bike. So again, you need to know what are the modes of transportation available for the public. And the fourth step in planning is traffic assignment. That means you need to know which streets people using it more than others, what are the transit routes that are being used. Travel demand forecasting, um, related facts to it in 1962, the Federal Highway Act was established, and at that time, this act requires that all cities with population more than 50,000 people must have a comprehensive long-term transportation plan, and that plan should be continually updated every few years. So why is that? Because again, people are growing. So for example, our city is much more than 50,000 people, so we do have a transportation planning. And typically each metropolitan planning organization, which is the MPO, is required to prepare a long-range plan or transportation plan, typically again for the next 20 years, and transportation improvement program, and that is updated at least every 2 years. So, and the city of Tyler, they have their own MPO, and I recommend you again to go to the website cityoftyler.org and look for the Tyler Metropolitan Planning Organization. They do meet and they have public meetings, and you're more than welcome to attend those. But as I said, this MPO for every city that is more than 50,000 people, they have to meet regularly to come up with transportation involvement program every 2 years and a long-range transportation plan for the city in the next 20 years. As I said before, forecasting is not an easy task. And here I'm bringing two um, quotes that I heard before. And the first one is, we have two classes of forecasters: those who do not know and those who do not know that they don't know. So again, it's a very interesting fact, but that's actually what it is. So you need to be careful which category are you going to be under. The next forecasting quote is from Alan Kirsten from Motorola. He said the following. He said, trucks of the future will have only a man, a dog, and a computer on board. The computer will be there to control the truck. The man will be there to watch the gauges, and the dog will be there to bite the man if he attempts to touch anything. So, and again, this quote was 5 years ago, and now we could see that there's lots of driverless cars and autonomous vehicles and connected vehicles that they don't need you as a driver. You just gotta be there and watch the gauges, and it's coming. And that forecasting again is becoming a reality in our daytime. Another part of you or some of you will be interested to be a transportation engineer, but into the design area rather than planning. The design aspect of transportation engineering includes the following. First, the sizing of transportation facilities. For example, how many lanes per direction am I going to be designing this highway for? What's the capacity of that facility? How many vehicles do I need to handle per hour or per day or per year? You also need to determine the materials and thickness used in the pavement. So, and again, we're going to be covering this in the last third of the semester, is pavement engineering. We all drive on highways or streets, but we need to know now as transportation engineers, how many layers do I need to pave, and what's the thickness for each layer, and what's the characteristics for each one of those layers. As a transportation designer, also you will be designing the geometry, the vertical and horizontal alignments, of the roadways, and that again there will be a big chapter for in this course to cover that. So all these are again elements under transportation engineering, the design aspect. When it comes to the road design, again we said there is a geometric road design. Under the geometric road design there is highway engineering. You need to design the grade, again how steep is the roadway, is it going uphill or downhill, what's the surface texture, is it too smooth, which is again it's very dangerous in rainy conditions and in icy conditions. Is the surface is too rough? That means it's gonna affect the vehicle and it will have a higher fuel consumption. So you need, again, as a traffic engineer or transportation engineer, you need to gauge that and have an optimal surface texture. The sight distance, how much distance do I have as a driver and in front of me once I see a danger? So that also is important. If I have enough distance, I'll be able to hit the brake, react fast, and avoid an accident. If there is not much sight distance, accident may happen. Also, you need to design the horizontal bends and vertical slopes. That's also important. The horizontal bends and horizontal slopes, again, will be covered in a full chapter in our class. Design speed. What's the speed limit for this highway? 40 miles per hour, 75 miles per hour? That's a big factor. Also, the structural road design, as we said, we need to ensure that the road is strong enough in terms of thickness wise and material wise that we're using to pave. It has to be strong enough to handle the expected number of vehicles and certain amount of years. And there is another aspect that probably we're not going to cover in this class is airport design. As a transportation engineer, as a civil engineer, one of your jobs or one of your careers might be an airport designer, which is pretty cool. I dealt with it before. Again, we can talk about it later on. Another aspect of transportation engineering is operations and management. So far we talked about planning, we talked about design. You can also deal with operations and management. So operation and management involve traffic engineering so that vehicles move smoothly on the road or the track. So for example, older techniques when it comes to operate and manage transportation system include signals, signs, markings, but now newer technology that talks to the drivers is, as we mentioned previously, the ITS methods, the Intelligent Transportation System techniques. You all use your Google Maps or Waze or Apple Maps. Those are another ways to give you directions, estimations, how long it's going to take you to get to your destination, if there is any traffic on your way, if there is any accidents. Again, those are some of the tools that they are used to operate and manage traffic systems. Um, Transportation engineers, what's been done? What's the role of engineers when it comes to transportation? So civil engineers are just some of the large cast characters that professional involvement in creating and running the transportation. So as I said before, as a transportation engineer, you'll be handling planning or design or operation. The profession involves are a lot. Again, as a planner, as a traffic and transportation engineer planner, you will be dealing with economists, you're dealing with financial analysts, you deal with social scientists. Same with design. Design, again, you'll be dealing with people from hydrology, drainage, electrical engineering, mechanical engineering. Operations, you will be dealing with businesses, transportation systems, administrations, economists. So expect that you will not be the only um, person to handle all the transportation system. You will be dealing with engineers as well as non-engineering people, and you need to be prepared to, again, to have a good background and to have the good knowledge how to interact with others in a team that handles any transportation system. Um, when it comes to transportation engineering, how are we organized in the States? The majority of decisions on consumption and provision of transportation in the US is made by individuals and private concerns. The principal private providers of transportation are, of course, the trucking companies. Trucking companies have a big voice when it comes to transportation engineering and how is it managed. Railroads, airplanes, airlines, pipelines companies, shipping companies, vehicle manufacturers, freight for forwarders. So other key agencies that you might be interested to know about is state and local public utilities. Also Federal Interstate Commerce Commission, Department of Homeland Security, and as well as so many others, all the way to the end of the list, which is the MPOs, which is the Metropolitan Planning Organizations. The U.S. Department of Transportation was formed in 1967. This is the overall um, umbrella, if you will, that transportation engineer is under it. So it has undergone several changes, and when it comes to its organizational structure, the Secretary of the Transportation is a member of the U.S. President's Cabinet. So it's very important to know that the the Department of Transportation, the representative, gets to get with the president a lot and discuss things. So it's important. The U.S. DOT currently contains the following operating administrations. There are several entities. One of them is the Federal Aviation Administration, which is FAA. Another one is Federal Highway Administration, FHWA, as well as others. Other federal agencies with transportation-related roles, one of them is the Department of Homeland Security. The other is U.S. Forest Services or the National Park Services, all the way to the Indian Affairs. All those, again, they are federal agencies that deals with transportation engineering. How about national professional societies that I highly recommend you to explore and be a member of if you decide that transportation engineering is your passion? First one is AASHTO, and some of you may know, or now you'll get to know that sometimes in exams they ask about acronyms, so be prepared. AASHTO is the American Association of State Highway and Transportation Officials. And this is the website for them, www.ashto.org. And another one that I recommend, TRB, Transportation Research Board, www.trb.org. This is a national conference that is held in Washington, D.C. every January, and about 15,000 people across the globe, they meet for a week to discuss anything has to do with transportation engineering. ASC, of course, American Society of Civil Engineers. ITS, Intelligent Transportation Society. So again, those are a good list of the transportation-related professional societies that I highly recommend you to join. Most of them, I think they are free if you are still a student. When it comes to state or regional or county level organizations, so state transportation highway departments. So TxDOT is one of the biggest DOTs, one of the biggest departments of transportations across the nation. There's so many offices, and there is actually a very good career for so many of my previous students. They ended up working for TxDOT. There is regional, county, and even city level organizations. There's MPOs, as I told you before, Metropolitan Planning Organization. There is regional planning affiliations. There is Department of Public Works. There's Department of Transportation or Highways. There's Department of Planning. There's Department of Traffic Engineering. All those again under the city. For example, our own city, we have traffic engineers. We have traffic engineering and transportation engineering department. Those are good places that can be, again, your career can land. So speaking of careers, job opportunities for transportation engineers, there is a lot of need and demand when it comes to transportation engineering. Opportunities for civil engineering, again, depends on the specialty. So if you are interested in planning, that means you might be estimating air travel demand or facility size. Design, again, you can be designing an airport to meet the demand. Construction, you can be dealing with a constructing a highway or even an airport. Um, Operation, you can also operate an airport, allocate gates, manage flows. And maintenance, you can also be dealing with maintenance, how to repair, renovate, and recondition highways. As an engineer, you must consider safety. Again, something again to always remind you: safety, public welfare, environment. This is very important. Before think of anything else, you've got to think that this facility is a safe facility. And then next will be, of course, you need to think of your budget and how can you fit your needs within your budget. For example, again, aircraft noise standards, something to consider. Benefits, cost, and operations and profits, well, something also to think of. And eventually, quality of life, quality of service. How would you like to design your highway to be safe, economical, and is it a very top-notch transportation facility that people would be happy to use? And of course, you need to assess your risks. This is just again a picture of what are the tasks that you can be doing as a traffic engineer when it comes to planning, design, construction, operations, and maintenance, and what are the needed training beside, of course, your degree that you'll be obtaining here. When it comes to the job opportunities in transportation engineers, if you decided to be a transportation engineer, 40% of the people trying to be transportation engineers, they end up working for the government, 50% as consultants, as private companies, 5% in research or teaching like myself, and then another 5% in the rail or trucking firms. Pay and perks, again, it's typically the startup salary, it can go as low as $45,000, which is not too bad. I think now it's got updated to 50 or 55, but you can get a 6-digit salary if it depends on the position. So again, it's a good career. Another thing, also producing tangible changes in the society. You'll always feel that you have the ownership, that you was a part of designing a highway or a part of designing an airport. Transportation engineers workforce in the United States are facing a shortage. Why? Because there is a lot of transportation engineers that are retiring or they're getting close to retire. So there is a big need for young, fresh transportation engineers. I think that I was tracing myself. So 50% of the state transportation workforce will be eligible to retire within the next 10 years. The good news also, as a civil engineer in general, CNN lists civil engineer as one of the top 30th best jobs in America. Last thing I want to mention for this chapter is make use of online resources. You guys are the generation of the internet, and you need to make sure that you are following up. There are lots of information on the web. Make Google Scholar is your friend. Take advantage of what you have. The first homework will give you an opportunity actually to give you some practice of doing so. With that, again, we finish chapter 1, and thank you.